you by pieces123.com. I learn and teach online.
Here's the next question, number 39. The open loop transfer function of a unity feedback control system is given by g of s is equal to k into s plus 1 divided by s into 1 plus ts into 1 plus 2s. That k is greater than 0, t is greater than 0. So the closed loop system will be stable if we have our 4 options. So this question is taken from control systems subject, and we will have to note that for the closed loop system to be stable, there is a certain characteristic equation that we have to keep in mind. The characteristic equation for a closed loop system being stable is 1 plus g of s into h of s is equal to 0. So here it is given that it has unity feedback control. So h of s is 1. Now let's substitute. We have 1 plus g of s is the system given here, k into s plus 1 divided by s into 1 plus ts 1 plus 2s into 1 is equal to 0. 1 plus g of s into h of s is equal to 0. So now let's simplify. When we simplify, we cross multiply and get the common denominator and so on and so such. So s 1 plus ts into 1 plus 2s plus we have the second term k into s plus 1 is equal to 0. Now let's open up the brackets and multiply. We have 2 ts cube, so that's s times s times s, 2 ts cube plus 2s square plus ts square plus s plus sk plus k is equal to 0. Now I've opened up the brackets and I have written it down. Now let's take the terms s common. So we have here 2ts cube plus, taking s square common, we get 2 plus t plus s common 1 plus k is equal to 0. So now that we have it in terms of s, let's use Ruse criteria in order to find out the stability condition. So we are going to use using Ruse criteria. We put down the powers of s here, s cube, s square, s1 and s0, and then we start with the table, the Ruse criteria table. So we have s cube here. Now s cube 3 is an odd number, so we write down the coefficients of the odd terms here. So the coefficient of s3 is 2t. Then next the coefficient of s, because this is s power 1 and that's an odd number, so that would be 1 plus k. That's it. Now for s square. For s square we take the even powers of s. So first term is 2 plus t and the second term is k, because that's a constant, s power 0. Now we will have to solve, or we have to write down the elements for s1 and s to the power of 0, s to the power of 1 and s to the power of 0. So this term here, in order to find that, we have to use the 4 terms above it, these 4. So it is, we always go from the left to the right, always remember that is left to the right. So it's 2 plus t multiplied by 1 plus k minus k multiplied by 2t divided by the first term that we started out with. So here s to the power of 1 would be 2 plus t into 1 plus k minus k into 2t divided by 2 plus t. Now the second element here would be 0. So I hope you're following. This is the first row and this is the second. First column and this is the second. So the second is 0 here because we don't have the third column's elements here. So this would be 0. This is the first, this is the second. So now for the bottom, s power 0, we do the same thing. We have to multiply this element here with k. So we are moving from left to right again. So this element into k minus 0 into 2 plus t. Now in working on that, we get the result as k. Okay, so we get the result as k over here. Now I think I better write it down here on the side so that you will understand. So that would be like so first. So that's 2 plus t into 1 plus k minus 2tk divided by 2 plus t, this whole term into k minus 0. 0 into that is anyway 0 divided by this entire term because that's what we are starting with, divided by 2 plus t into 1 plus k minus 2tk divided by 2 plus t. So in this part you will notice that we can cancel these two terms out and we are left with k, and that's how we get k here. Okay, I hope you follow there. Now the next step here is to see, the question tells us that k is greater than 0 and t is greater than 0. Now for stability, k should be greater than 0. Therefore this term here should be greater than 0. Okay, I'll write that down here. For stability, the importance is given to k. K should be greater than 0. Therefore, this term here, that is 2 plus t into 1 plus k minus k into 2t should be greater than 0. The entire thing divided by 2 plus t should be greater than 0. If you take the denominator to the other side, it's anyway 0. So we're going to concentrate on the numerator here. Okay, so it's 2 plus t into 1 plus k minus 2k t is greater than 0. Now we have 2 plus t into 1 plus k minus 2tk greater than 0. Let's write it in terms of t, taking k common here. So that's k into 2 plus t minus 2t plus 2 plus t is greater than 0. K into 2 minus t, now I'm solving, plus 2 plus t is greater than 0. Now this would become k into 2 minus t is greater than minus of 2 plus t. So we need it in terms of k. So if we are to divide by a negative term, you know that the sign flips over. So k becomes less than t plus 2 divided by t minus 2. I hope you see what I'm doing over here. Taken k here, so k is less than t plus 2 divided by t minus 2. And to complete it, we know that k is greater than 0. So it lies between 0 and t plus 2 divided by t minus 2. And this resembles option number C. Right. So C is the right answer for this question. I hope it has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.